Hello and welcome to tribetopper.com.
And you're watching this video on motion in one dimension. In this video, you're going to learn about how to find out an object, whether it's in motion or at rest. How do we define it? And let me tell you, the whole world and everything in it moves. I mean, even the objects that appear to be stationary to us, they are moving. All the atoms, molecules, planets, stars, galaxies, all of them are in motion. And how do we perceive the motion of an object? How do you say an object is in motion? So suppose a ball is lying here, right? This is a ball, and suppose you saw it at some instant, say t. It was lying here. When you just kicked it with your foot, it started rolling, and say it reached here. Now you see that this object has changed its position. So suppose here the position was x1, then here is the position x2, and you can make it out because you can see that the position of the object is changing with respect to the surroundings. You might be having something around you, and according to that you can make out that okay, the position of this ball has changed, maybe in 2 seconds, 5 seconds, whatever time, with respect to its surroundings. So that is why we can say that it is in motion. But before that, when it was lying here, it was not changing its position, so it was at rest for you. So we can say that we perceive an object to be in motion when its position changes with time with respect to its surroundings. So change of position with respect to the surroundings is an important aspect of motion. And since we are going to study about motion in this chapter or in this video, so I want to ask you here, do you know what causes the phenomena of sunrise, sunset and change of seasons? Of course, you have been learning this right from your junior classes, that all these phenomena, they happen due to the motion of the earth. You know that earth rotates around its axis. So this is here, I've shown you the rotation of earth. It rotates about its axis, and at the same time it revolves around the sun. So if here is the sun, then earth is revolving around it. So there are two motions that earth is exhibiting here. One, it is rotating about itself, about its axis, and it is also revolving around the sun. And both these motions, they cause the day and night, or the sunrise, sunset and the change of season. But now the question arises that if it is true that earth is moving all the time, why are we not able to directly perceive this motion of the earth? Why can't we see that earth is moving, or some objects sometimes which appear to be stationary to us? How do we say they are in motion? So let's look at this example. Here we have a cute little girl and a cute little boy sitting in a train. Now when both these are sitting inside the train and the train is moving. So the train is moving. Do you think that with respect to each other, they feel that, like for the girl, does she feel that the boy is in motion, or the boy feels that the girl is in motion? No. The passengers which are sitting in a train, for them, they do not appear to be moving to each other. But at the same time, if somebody is standing here outside on the platform, right? So this is somebody standing on the platform. Then for this person, the train is moving. So hence these two passengers, or all the passengers for this person, will be in motion. Similarly, you might have noticed many times, like on the roadside. So these trees on the roadside, they will appear to be moving to the passengers sitting in the bus backwards. You might have noticed this many times when you are moving in a car. So the trees, they appear to be moving back and you are going forward. So anything it appears to be moving to you backward. But if someone is standing here waiting for a bus, for him all these trees, they are at rest. So what can we say here now? Or what is the conclusion? So we understand here that the motion of any object is visible to an observer depending on his position in accordance with a reference point, which is known as the frame of reference. So a frame of reference is, we can say, a reference point where one is standing and where the observer is standing and where the motion is happening, and these two things might be happening in two different frames. For example, when we talk about a passenger in the train and the other person standing on the platform, we refer to two different frames of reference. The moving train is one frame of reference and platform is another frame of reference. That is why the objects which appear to be stationary to the passenger standing on the platform, they might be in motion for the people moving out, moving in the train. So we can say that to a person on another planet, we will appear to be moving, but we may be at rest with respect to each other on the earth. So when you and me are sitting in front of each other, we might be at rest with respect to each other on the earth, but to somebody watching us from another planet, we are in motion. And to describe the motion of an object, we need to specify the position of the object in reference to a point, and that reference point is called the origin, like we draw the graphs. So this is called the origin, and we have to plot the position of an object. So along the x-axis towards the right, that is towards the right side of the origin, the distance is taken as positive, and towards the left side it is taken as negative. Similarly, you know that the distance measured above the x-axis is positive and the one measured below the axis is negative. So this is how we can measure the distance and specify the position of an object with respect to a reference point, whichever you consider as the origin. So I hope you understood that how rest and motion are relative terms and not absolute, and how do we find out anything is in motion or at rest. In the next video, we shall continue with the parameters to describe motion. If you find the video helpful,
please follow us on Instagram, Facebook, and Twitter at tribetopper.com.